Hello, in our last lesson, we have done the operations of two vectors or three vectors, adding, subtracting. And from this lesson, we are going to start to see the multiplying of two vectors. And for multiplying of two vectors, there are two types of multiplication. One is dot product, another one is cross product. So we are going to discuss the cross product in our next lesson. And the 7.3, 7.4 is corresponding to Nelson's calculus and vectors textbook. So the definition of dot product is A dot B equals magnitude of A times magnitude of B times cosine theta. And theta is angle between A and B, that is from 0 to 180 degrees. The formula is x component times plus y component times plus z component times. If you have only two dimensions, then there's no the A3, B3. The 1, 2, 3 represent 1 is x direction, 2 is y direction, and 3 is z direction. It's just easier to write, okay? And this application is in physics is work. So if you have learned the grade 11 physics or grade 12 physics, you know that the work is the force times the distance traveled under this force, and this equals the work. So the distance traveled must be in the force direction. If it's 90 degrees, then there's no work. So if we draw it, this is a displacement and this is a force direction. Then we are going to find the force on the displaced directions projection, then times it to get the work. So this is adjacent, so the force projection on this displacement is F times cosine theta, then times the delta D. So this is a work. And if we have the vectors in the component form, then we don't have to do this trigonometry calculation. We could just use a component x direction, y direction times, then we get the work right away. So it's more convenient. And how to prove it? You could use a cosine law. So you will see we have a triangle ABC. Okay, we have a triangle ABC. And actually, I want to use not ABC, we want to use OAB. Because if we use OAB, then we only have two vectors there, okay? So I will use AB. So this is O, this is A, this is B, so this is vector A, this is vector B, and from AB we know it is B minus A. And in this right angle, in this triangle, we could use a Pythagorean, the cosine law, that is B minus A, the magnitude squared. This is our O squared equals A magnitude squared plus B magnitude squared minus 2 magnitude A magnitude B, then times cosine theta. So this is our A dot B. So minus 2AB. And the magnitude of B minus A, the magnitude of A, magnitude of B, we can write them out. We just move everything to other side and simplify. We could get A dot B, the dot product. why this is a dot b, you could think this is b minus a, bracket squared, expanded, b squared minus 2ab plus a squared. Okay, and compare this one with this, you will find out that this 2ab is just this magnitude a times magnitude b times cosine theta. So they are connected. Okay, then we are not going to derive this formula, we are going to use it right away. Okay, so we have example 1. Given two vectors, this is 2 dimensions. Find the dot product of u and v, and after that it also asks you to find the angle between u and v. So instead of we draw the triangle and use a cosine law to find it, we are going to use this formula to find it. Okay, so 1a u dot v equals, we know this is a1, a2, this is first vector, b1, b2 is our second vector, then it will equals to just the x coordinate. 1 means x coordinate, a is first vector, b is second vector, then plus a2 times b2. Or you could write it as u1 v1. Okay, or you just write it as u1 v1 plus u2 v2. So u represents the component for u, 1, 2 represent the x, y direction. Okay, then we sub in the numbers. So -5 times 1 plus 2 times 4. So integers multiplying, dividing again. So -5 plus 8 give us 3. So the dot product give us a scalar. So work is a scalar. Okay. And after that, we are going to see the question B. Find the angle. The angle formula, we have it here. So u dot v equals u magnitude times v magnitude times cosine angle theta. So uv we know is 3. What we need to know is u magnitude, v magnitude. So, and we have uv given. We could find the u magnitude and v magnitude. So it's square root a squared plus b squared, u1 squared plus u2 squared, or a squared b squared, v1 squared plus v2 squared. So this is x direction, this is y direction. -5 squared plus 2 squared is square root 29 v squared, v1, v2, 1 squared plus 4 squared is square root 17. Then we sub in both of them here. We are going to have 3 equals square root 29 times square root 17 cosine theta. In order to find the theta, we move everything to other side by doing opposite operation. This is multiplication, then division. To get rid of it to both sides, do the division. So 3 over square root 29 times square root 17, then equals cosine theta. Theta equals, we move the cos to other side, its opposite operation to cosine, its inverse of cosine. Then use your calculator, you will find out it's 82.23 degrees. Then this is done. So this is how to find the dot product and how to find the angle. Then we are going to just continue to practice and see more examples. So example 2. Prove that two non-zero vectors u and v are perpendicular if and only if u dot v equals 0. So we know that u dot v equals uv then cosine theta. So if u dot v equals 0, so we need to prove this equals 0, then perpendicular, and this perpendicular equals 0. So this if and only means backward or this way, both correct. So we are going to do if this correct, then is it true? If u dot v equals 0, then 0 equals u v magnitude cosine theta. It's said that non-zero, so it means the magnitude not 0. So we want to solve for theta. We move the magnitude u and v to other side by doing opposite operation, multiplication here, we do the division. Then we have 0 equals cosine theta. We solve for theta is inverse of cosine 0 give us 90 degrees. 90 degrees means the u and the v, they are perpendicular. So from uv dot product equals 0, we proved it's perpendicular. So u is perpendicular to v. This is true. Then second one, if u perpendicular to v, then we know the angle between the two vectors, theta is 90 degrees. Then we sub in u dot v equals magnitude u times magnitude v, absolute value means magnitude, cosine 90 degrees. Then cosine 90 give us 0, 0 times everything give us 0. So from perpendicular, we proved u dot v is 0. So therefore, if and only if and only if u dot v equals 0, then u is perpendicular to v. Okay, so both works. This is for A. So uv dot 0 proof is perpendicular. If perpendicular, u dot v must be 0. So both direction it works. Then question B. Based on the conclusion from the first one, it asks you what the key value will give you these two perpendicular. So we know if these two dot product equals 0, then A will perpendicular to B. So we just need to use A dot B equals 0 to set up an equation to solve for K. So A dot B is x times x, negative 1 times 3, y times y is 3k, then z times z is 4 times negative 2 equals 0. So this is a linear equation. We know how to solve it. So get rid of the multiplication first. Negative 3 plus 3k minus 8 equals 0. Linear equation. We need to isolate k. So move the numbers to other side. So 3k equals plus 3 plus 8 give us 11. Then we don't want to see the 3. Opposite operation is division. So k equals 11 over 3. So before, it will be hard for us to think how to prove two things perpendicular. Now, we know it's just find the dot product, let it equal 0, then that is perpendicular. Okay, and we are going to practice more on the dot product. So example 3, this is a dot product, but it's not, this one is in unit vector form. So 2i minus j dot j. Then we are going to, just like our multiplying, expanding of the polynomials, just monomial times binomials, then this each term in the bracket times with a monomial. So 2i dot j minus j dot j. So we know that I is on the x direction, j is on the y direction. So I and the j they are perpendicular. So if they are perpendicular, then I dot j give you 0. So we have this one is 0. 2 times 0 give us 0. And the minus j times j, they are same direction. Same direction times it's just j squared, and it's just magnitude. And the cosine will be 0 degrees because they are same direction. So it's just j squared. J squared is 1. So this is from the angles. If you don't want to use those angles, we could use I is component 1, 0. J is 0, 1 to do it. So jj is 1. So we have 0 minus 1 is negative 1. This is use angles. Okay. We have used angles for this one. Then another method, we just use a component. So we have 2, I is 1, 0, j is 0, 1, minus 1, 0, 1, 0, dot product. Okay. Then from here is 2, x times x, y times y. So 1 times 0 plus 0 times y, this is dot product, minus 1 times 1, then plus 0 times 0. This is a dot product, a1, a2, b1, b2. So a1, b1 plus a2, b2. Then this one is 0, 0 is 0. So 2 times 0 minus 1 times 1 is 1 plus 0 is 1. So minus 1. They give you the same answer. So it's up to you which one you feel more comfortable. So method 1, we use angles. If perpendicular, this one is 0. If same direction, it will be just the magnitude squared. So this one, we have the angle is 60 degrees. So it means we will want to use a dot b equals the definition of the dot product connected with trigonometry. So a dot b equals magnitude of a times magnitude of b times cosine angle. So equals 3 times 4, then cosine 60 degrees. Use your calculator, you will find out it is 6. So after that, we are going to expand binomial times binomial. Just use the same idea that we have used for the polynomials, binomial times binomial. So 2a plus b dot product a minus b equals first times first 2a times a, then minus 2a dot b, then plus b dot a, then minus b dot b. So the same direction the angle between these two will be 0. So 2 times A magnitude times magnitude times cosine 0 degrees. These two, they are like terms, will give us just minus A dot B. So A dot B is A, B, then cosine angle between that two. Then minus B magnitude, same thing, cosine 0 degrees. So cosine 0 degrees give us 1. So we only have 2A magnitude squared minus AB cosine 60 give us 6. So this one we collect the like terms. Negative 2 plus 1 give us negative 1. So that's the reason we have negative 1 instead of negative 2 plus. And this one minus B magnitude squared. Cosine 0 is 1. Then we sub in A is 3 squared minus 6 minus 4 squared. Do the calculation, we have 18 minus 6 minus 16 equals negative 4. So this is a magnitude given, the angle given. We are able to find the operations between the two variables A and B. And remember, A dot A is same angle, so it's just A magnitude squared. Same, because the angle between these two is 0 degrees. Cosine 0 give you 1. Okay, then the last example, example 4. Given 3 dimensions, for what value the y, this one, the vectors will be collinear. Collinears here is another term you need to know. So collinear, it means parallel. Okay. So if parallel, then we are able to write this as B is just a scalar times A. So A is here, B will be either this direction or another direction or shorter. So, but they are parallel, they are same direction. So it's just M times A. M could be positive, could be negative, but it is a constant. So based on this one, we write it out. Negative 6 y 18 equals M times 2 negative 4 negative 6. And here we need to make sure the xy direction, they are independent. So they have to equal to each other. Then we are going to write x direction is negative 6 equals 2m. Y direction is y equals negative 4m. Z direction is 18 equals negative 6m. So from these 3 directions, we want to solve for m. So first m, move the 2 to other side, m equals negative 3. The last one, move the negative 6 to other side, is m equals negative 3. So if we times a with negative 3, we get 2 of these numbers. So the middle one must be negative 3 times 8. So y equals negative 4 times negative 3 give us 12. So if y is 12, then it is true. We've put negative 3 here, so b equals negative 3a. They are parallel. And we call it collinear when y equals 12. Okay, so this is what collinear means. And question B asks you perpendicular. So perpendicular means 90 degrees, and we know that we have one formula with cosine, with angle. So that is A dot B equals A magnitude, B magnitude, cosine angle. If it's 90 degrees, we know it is 0. So we just need to find A dot B give us 0. A dot B is x times x, y times y, and z times z. So it will be A1 B1 plus A2 B2 plus A3 B3 equals 0, and A1 A2 A3 just x, y, z direction. So we are going to sub in. It will be 2 times -6 plus -4. And this is a separate question. So y is unknown. We have to find it. -6 times 18 equals 0. Then we have -4y. Move the other 2 to other side. This is 12 plus 108. Then move the -4 to other side. We are going to have y equals -30. So therefore, when y equals -30, A is perpendicular with B. Then this is done. So that is how we prove, or from perpendicular to find the variables. So what we have covered for this lesson is the dot product. It's one of the multiplication of two vectors. And the dot product equation is the magnitude of each vector times the angle between that two vectors cosine. So application is a work in physics. So, and if just use a component vectors, it will be the x direction times plus y direction times plus z directions times. So just the u1, u2, v1, v2, u1 times v1 plus u2 times v2 give us a dot product. In order to find the angle, we just use a dot product divided by the magnitude of each vectors, then cosine inverse to get the angle. And we could prove if perpendicular to vectors, then dot product is always 0. If dot product is 0, the two vectors perpendicular. So by setting up the dot product equals 0, we could solve for the unknown variables. So this is two vectors times in the unit vector form. We could convert it to the component vector form. It's up to you which one you want to use. If two vectors 90 degrees, the dot product is 0. If it's same direction, then it's just the magnitude of that vector. If we have A magnitude AB given, angle given, we could find all the operations of the two vectors. So just like the binomial multiplication, A dot A give us just the A magnitude squared, and A dot B give us A magnitude times cosine angle. Same vector means the angle is 0. Then we just apply. If collinear means parallel, they need to be in proportion for each x, y, z coordinate. And if it's perpendicular, it's just cosine 90 degrees, dot product equals 0. So thanks for watching.